Let us start with the topic right shift operation. It is similar to left shift operation, and in this operation, what do we do? Let us say we have a decimal number A. We are right shifting the bits of this decimal number by B. So this A is the decimal number, and B is a let's say 1, 2, 3, any number, also a decimal number. We will shift the bits of this A B number of times. So if I let us say write 179, right shift 1, I will shift the bits of this 179 decimal number by one position to the right, all the bits. Okay. So this 179 number, I have given you an example here. This number 10110011. Let us make a box because in a register we have 8 bits. Okay, and let us see what will happen after we shift these bits. 1, 2, 3, 6, 7. Okay, so now let us start from this position. We shift. Let us say we shift the 179 by 1. The bits of 179 number by 1. So this will come here. This will come here. 0. This will come here. 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 And this will be discarded, and we will add 1 0 to the left. As we were doing in the left shift, where we were adding 0 to the right, we was adding 0 to the right. Here we will add 0 to the left. And then this number we will convert in decimal. So this will be what? Actually 179 divided by 2, and nearest or the floor value of this 179. So what is 179 divided by 2? Actually it is actually you can say 89.5, but we will take the floor value, so our answer is 89. Now the thing is, remember as we talked that when we do a left shift we used to multiply, right? Let's say we were doing a we were doing a left shift by B. This will be equal to A into 2 raised to the power of B. Now when we are doing a right shift, this will be equal to what? Effectively divides the number by 2, rounded down to the nearest integer. Okay, so it will be A divided by 2 raised to the power of B. So here we had 179, we were shifting right by 1. So the answer will be 179 divided by 2 raised to the power of B, and B in this case is 1, so 179 divided by 2 raised to the power of 1. So it will be floor value. What is the floor value? Let us say we have a number 89.5. The floor value will be 89, and the seal value will be 90. So floor is the nearest decimal number, nearest decimal number after rounding off at like one number less. So 89.5, when we round off, it becomes 90, and the floor value of this will be, we will discard this and we will take 89. Okay, so in right shift we simply divide A divided by B, 2 raised to the power of B, and in left shift we do A into 2 raised to the power of B. This one is left shift, this one is output. So if I give you any number, let's say x, okay, and I do a right shift by b, so you can easily tell me what will be the answer. It will be simply x divided by 2 raised to the power of b. So if x is, let's say, 6 and b is 1, so answer will be 3. So if I do 6 right shift by 1, I will get 3. And let us see how. So what is 6 in binary? We have discussed in previous videos what is 6 in binary. It is simply 6 in decimal is 16 decimal. Yeah. This is 16 decimal, and binary it is 10110 2. So when we do a right shift by 1, let us make a box. 1, 2, 4, 5, 6, 7, 8. 0, 1, 1, and let us fill the rest with 0. And then we do a 3, 4, 5, 6, 7, 8. So this goes, sorry, yeah, this goes here, this is discarded, and this goes here. So 1, 1, and then simply you add 0 here. So this 6, what is 1, 1? It is 3, right? 1, 1 from binary is 3 in decimal. So without even doing this calculation, I told you, right, that 6, when you do a right shift of 6 by 1, you get 3. I easily told you without doing this operation, because I know that when I do a right shift of by b, I what is the answer? A divided by 2 raised to the power of b. So right shift operation is simply dividing it by 2. If I was doing, let's say, a right shift operation of 6 by 2 times, it will be 6 divided by 2 raised to the power of b. And what is b? 2. So it will be 6 divided by 4, which is equal to 1.5, but we will take the floor value. Floor is the nearest decimal number that is less than 1.5. So it is 1. So answer is 1. Okay. So what is the use case of doing right shift operation? See, as I have written here, dividing division by power of 2, right shifting a binary number by n position is equivalent to dividing the number by 2 raised to power n, as discussed here. Fast integer division. Okay, so we can easily, for positive integer, right shifting can be fast way to perform divisions by power of 2 compared to by using the division operator. Okay, so if you are doing programming, this right shift will become very easy. I can simply do x equal to x this to divide it by 2 instead of doing the whole calculation of this, x equal to x divided by 2 and all. So this is a faster way of doing a dividing the number by 2. Okay, arithmetic operation, right shifting can be used in various bitwise arithmetic operations and optimizations. Okay, so this is right shift operation. You can practice more problems after the video, but this is an easy concept similar to the left shift operation.